Okay, in this video we're going to start with question number 14. So always make sure you read the information that they give you. So above question 14 it says, in the diagram to the right, ray BD bisects angle ABC. Okay, that's important information because if BD is bisecting that angle, then I know that this angle right here and this angle right here, right here, are congruent. Okay, so that's going to be important for me. Find the measure of angle ABC. Okay, that's the big angle. So, to get that measure, I'm going to add the two little angles together. And I already know the two little angles have the same measurement. So, but I don't know what the measurement is yet. So let's set at 5x minus 11 equal to 4x plus 1. Okay. So I just gave myself some place to work. So since 4 is smaller than 5, I'm going to bring the 4 to the left. So minus 4x minus 4x, that gives me x. Now I have to move the number to the opposite side. So plus 11, that's going to give me 12. And I've already completed my solution of finding x. But I'm not done because they don't want x, they want the entire big angle. So why don't we take the bottom of the angle, which is 4x plus 1, and plug in our x there. So if I plug in the 12 there, I'm going to get 49. So if I know the bottom of this angle is 49, don't I know the top of it is also 49 because of the bisecting information that they gave me here? So if this is also 49, then it looks to me like angle ABC is going to be 49 plus 49, or 98 degrees. And that one's done. So that's 14. Look back and make sure that you key in on the fact that a bisector divides an angle in half, and that you see how we arrange the equations to begin our work. Okay, in question number 15, it says the measure of angle 1 is 72 degrees, and then it says find the measure of its complement. So remember, a complement is 90 degrees, so you've got to memorize that. A 90 degree is the sum of complements. So if you say you have two angles that sum to 90 degrees, then they are complementary. So I have one angle that's 72. To find its complement, I'm going to say 90 minus 72, and I'm going to get 18 degrees. So 18 degrees is the complementary angle to angle 1. 18 and 72, which was the measure of angle 1, equal 90. Those are complements. Okay, question 16. I have the same measurement. My angle 2 is 72 degrees. But then it says find the measure of its supplement. Supplementary angles sum to 180. So this time, we're going to say 180 minus 72, and we're going to get 108. So the angle 108 and the angle 2, which is 72, are supplements because they sum to 180. Okay, that brings us to question number 17, which is related to question number 15. Okay, question 17 says that angles A and B are complementary angles. And they would like us to find the measure of each of those angles. So if they're complementary, you should know that they're 90 degrees, okay? You have to know that. It's not optional. We use that quite often, so you want to definitely know that. Okay, so I know right away that angle A plus angle B has to be 90. But then I look and I see what information they gave us. Look at this. So if I want to figure out what each angle measures, I have to use these equations. So wherever I have an angle A, I'm going to put the equation for angle A, which is just A equals X. I'm just going to put the X. Okay, plus angle B is equal to 2X minus 75, and that has to equal 90. Okay, on your left side, combine your X's, 3X. Add 75 so that I can add it on the right, so that I have numbers on one side and x's and the coefficients on the other side. So at this point I have 3x equals 90 plus 75, so that's 165. And then if I divide both sides by 3, I get x equals, let's see, what do I get? It's 55 degrees. So I'm not done, because I have to find both of those angles. So if I knew that angle A equaled x, then right away I know angle A equals 55 degrees. If angle B is 2x minus 75, to get angle B, what I have to do is say 2 times, here comes that 55 again, because that's my value for x, minus 75 will equal my value for angle B. So if you do that work, 2 times 55 will be 110, right? 110 minus 75 is going to get me 35 degrees. And when I add those angles up, I do indeed get 90, so I know that they're complementary. So I'm happy with that work. All right, we're going to go on to number 18, but I'm going to shift everything up a little bit. Okay, turning to number 18, I see that angles A and B are to be supplementary angles. Supplementary angles, 180. So they want me to find the measure of A and B, so this is very similar to problem 17. So since they're supplementary, I know that angle A plus angle B will equal 180. So now let's use the equations or the expressions that I have for these two angles. So A is x plus 50 plus B is x plus 100, and this has to equal 180. Okay, let me just make sure that this looks like 100. So I'm going to clean that up a little bit. Okay, so just like we normally do, let's combine our x's first. On the left-hand side, I have 2x. Add your numbers on the left-hand side, and I have plus 150. Still equals 180. Since I have numbers on the right, let's move the other number over there as well. So I end up having, this is now 30. Okay, so 2x equals 30. So that must mean that x equals 15 if I divide both sides by 2. Okay, so x is 15 is a means to an end for us. It's not my answer, but it's the way I'm going to get my answer. So look at measure of A. A is x plus 50. So if I just found out that x was 15, A is 15 plus 50, which is 65. Okay, so we've got one angle done. Okay, the second angle, angle B, is x plus 100. And since x is still 15, 15 plus 100 is 115. Now, just make sure that when you add 65 and 115 together, you get 180, which you do, because then you know that you must have this correct, since you know that those two angles are meant to be supplementary. Okay, so we've got 2 more problems on this page. Alright, so on this page we have 2 problems. So we're going to focus on 19 first. So when I look at those 2 problems, I see that I have 2 variables. I have x's and I have a y. So I can't solve a problem if I have an x and a y in one equation. I can only solve a problem if I have x's in that one equation. So let's see what we can figure out. If I look at this, if I look at this line right here, I'm picking out a linear pair. Do you see that linear pair? Now that linear pair is going to help me figure out what x is. When I add those two angles together, they should sum to 180. I have a second linear pair that I'm going to point out, but we're not going to use right this minute. That second linear pair is right down here. They will also sum to 180, but I can't solve for x or y because I would have both an x and a y in one equation, and that's not going to work. So I'm going to wait on that one for just a moment, and we're going to go back and we're going to work with the first green linear pair. So that linear pair tells me that 6x plus 15x plus 75 has to equal 180. So I have one variable type, it's x, and one equal sign, so I can solve this problem. So 6x plus 15x is going to give me 21x. So this is 21x plus 75 equals 180. So this is a two-step problem now. Here's step 1, move the number. So that's going to give me 105 equals 21x. And when I divide both sides by 21, I get x equals 5. All right, so that's going to help me. So let's, I'm going to give myself some more room. So we will get rid of this problem for right now, and we'll use our space to work on this first problem. So I have a value for x. That's all they wanted. Now I'm going to change to pink because I'm going to use that other linear pair to solve for y. So let's put a nice line kind of down here separating out this problem. Okay, so going back to pink, and I'm picking pink because that's the linear pair that I'm going to work on next. So that is 6x plus 3y. Since it's a linear pair, it's going to also equal 180. Now, this is a problem if I don't substitute in my x. I know that x is 5. So 6 times 5 will be 30 in just a second. But I'm going to rewrite my problem with my x being replaced by the 5 value that I figured out in the green work. 6 times 5 is 30. 30 plus 3y equals 180. Subtract 30 from both sides. 3y equals 150. That's going to make y equal 50 once I divide both sides by 3. Alright, so now I have values for x and y. So if I plug them in, I'd be able to verify that I do indeed have angles that sum to 180 on the linear pair. So I'll leave that for you to do, and I'm going to go and set up problem number 20 next. Okay, problem number 20 is very similar to problem 19, and I'm seeing I have x's and I have y's in this problem. So first find the linear pair that has only x's in it. There it is. Now I'm going to change to pink again, and I'm going to look at the linear pair that has y's in it. So that is what I have. So let's go ahead and we'll solve the green one first, and we'll get the value for x by doing that. So since they're a linear pair, just like in 19, those two angles will sum to 180. So combine my x's minus, minus 41 equals 180. Okay, so now, two-step problem. Move my number. You always use the opposite operation. Okay, and then I have 17x, divide by 17, divide by 17, and I end up saying x equals 13. So just go and look at the math and verify that I have done that correctly. So I now have one variable. So now we're going to divide our work. And go over to pink, and now we're going to deal with the other linear pair. So that other linear pair says that 5x plus 5y, also a linear pair, has to equal 180. So I have an x and a y in one equation, which means I can't solve it unless I use the information that I just gleaned by solving the green, which told me that x equals 13. So let's do that. So I have 5, replace the x with a 13, plus 5y equals 180. Okay, we need to do a little math. Let me just clean this up. So, do a little bit of cleaning. Okay, so that should have been 180. Okay, 5 times 13. 5 3s are 15. Carry the 1. 5 1s are 5, and 1 more is 6. So that's 65 so far. So 65 plus 5y equals 180. So that means 5y equals 180 minus 65. So 5y equals 115. Divide both sides by 5. And I'm getting y equals 23. Okay, so now I have both values. So that solves my problem. And if you were to plug in for each of these equations up here, up in here, you would find that you do indeed have linear pairs, and that would be wise to check. But for our purposes now, we're done with that. So we're going to continue on to the Chapter 3 material in this video. Okay, so in this page we're doing Chapter 3 review, and it says state the relationship between the angles using the following terms. So our terms are linear pair, we just talked about that, they sum to 180, vertical angles, which are always equal, consecutive interior, which means they're on the same side and on the inside, but on the same side as the transversal, alternate interior, inside but on opposite sides of the transversal, alternate exterior, outside and on opposite sides of the transversal, and corresponding angles which have the same address. So they're always in the same spot in relation to their position with reference to the transversal and the parallel line. So let's get started on what we're going to be recognizing. So angles 1 and 2, which are right here, they are a linear pair. So linear pair is what we want there. Okay, then angles 2 and 3. So look at angles 2 and 3. We'll change color a little bit. So 2 and 3, they're here and here, and they're across from each other, and they cross over a vertex. So those are vertical angles. Okay, so we're going to do some work as we go. So linear pair, they sum, that's the sum symbol, to 180. Okay, so they sum to 180. You want to know that. Vertical angles are always congruent. Okay, so 1 and 5 come next. So let's get rid of some of this writing right here. And we're going to look at 1 and 5, so I'll change colors again. So here's 1, here's 5. So notice, both these angles are to the left of this transversal. They are both above their line. So if they have the same address, they're both to the left of the transversal and above the line, then they are corresponding angles. So we're going to write corresponding angles. And they will always be congruent. So we're going to write that little notation here for ourselves. Okay, so next we're going to go and look at 4 and 5. So we will change. Okay, so 4 and 5. So they are inside, right, because this area in here is in between the parallel lines, and one is to the right of the transversal and one is to the left. So that makes them alternate. Let me spell this correctly. Alternate interior, I'm going to abbreviate INT, angles. Alternate interior angles are congruent. So 4 and 5 are alternate interior angles. Okay, so let's erase this. We're going to go to the next problem. Okay, the next problem asks us about 4 and 6. So 4 and 6. 4 and 6 are inside, and they're on the same side of the transversal. So the textbook calls those consecutive. So I'm going to abbreviate that way. Consecutive, so it's this word right up here. Interior angles. And consecutive interior angles will sum to 180. Okay, so they're just like linear pairs in that they both sum to 180. Okay, and the last one we're going to do has to do with angles 2 and 7. So 2 and 7 are this angle, and they are both outside, so they're exterior, and they're alternating on either side of the transversal. So they are alternate exterior angles. So alternate exterior angles, right up here is that word. Okay, so those are also going to be congruent. So that's some information for us about question number 1. Now, that's a lot of information because it tells us not only the names of these different angles when they're assigned to a transversal that's cutting a pair of parallel lines, but I also took a second to figure out how those angles are related. So you want to go back and understand all of that, because when we work on the next problems on the bottom of this page, we will absolutely need that information. Okay, so here's question number 2. And so they want me to find the missing angles. So I see I have parallel lines, and I know they're parallel because I have these little arrow symbols. So I have parallel lines that are cut by a transversal, and here's my little transversal right there. So the question is, how do I solve for these angles? Well, looking back on the work we did in the previous question, I know that angle 1 and angle with 80 degrees are corresponding. They are both above the line and to the left of the transversal. Corresponding angles are equal, and therefore angle 1 will be 80 degrees. Look at angle 1 and angle 2. Angle 1 and angle 2 are vertical, and because they're vertical, they are equal. And if they're equal, then that means angle 2 is also 80 degrees. All right, so you had to know that angle 1 and angle 80 were corresponding angles, and you had to know that angle 1 and angle 2 were vertical, and you have to know what that means in terms of the values. Okay, so let's look at the next part of angle 2, of question 2. So do you see how 50 and angle 1 are vertical? So right away, I know that 50 degrees has to be the value for angle 1 because vertical angles are always congruent. Okay, so then 50 and 3 have a special role. They are alternate interior angles, and I will tell you that these lines are parallel. So 50 angle 50 and angle 3 are both alternate interior to each other. Alternate interior are congruent. Therefore, angle 3 is also 50 degrees. Okay, angle 2 and the 50-degree angle right here are a linear pair. So therefore, those guys are going to sum to 180. So 180 minus 50 is 130, and that's the measurement for angle 2. Okay, so let's finish this page on my next slide. All right, so here in the first, we'll call it A, in this first problem, I see that I have 65 and x plus 12. These two angles are alternate interior, so they are congruent. So to do the math, I would say 65 equals x plus 12. Subtract away the 12 from both sides, and I'm going to get, what, 53 equals x. So x will be 53 degrees for question A. Okay, let's call the one right behind it, or right in the bottom of it, question B. How are these two angles related? Well, I see my parallel lines. I see they're on opposite sides of the transversal, and they're on the outside, so they are alternate exterior. So set them equal, because alternate exterior are indeed congruent. So there we are. So subtract 15 from both sides. So if I subtract 15 from both sides, I get 90 equals 3x. Divide both sides by 3, and I'm getting x equals 30. Okay, so x equals 53, x equals 30. Let's clean up a little bit of our work. You've seen what I've done. I want to work on the other two problems on the other side of this page. So I'm going to do a little quick erasing. And you can always rewind and see what I've done. But now let's continue. So we're looking right over here now. So I see those two angles. Those are consecutive interior. Okay? Consecutive interior, if you look back on your notes, are going to sum to 180. So in order to solve for that x, I'm going to say 130 plus 2x minus 70 will be equal to 180. Okay, so let's clean this up a little bit. So what is 130 minus 70? Okay, so you should say 60, and you certainly should be using a calculator for this if you have any doubt. So 60 plus 2x equals 180. Okay, so subtract 60 from both sides, and I'm going to get 2x equals equals 20, because 180 minus 60 is 20. So 2x equals 20. And then do I have, oh, I'm so sorry, 2x equals 120. What am I saying? Okay, 180 minus 60 is 120, so therefore your x will be 60. Okay, so x equals 60 right here, and we got that because we knew that those two angles were consecutive interior angles, and consecutive interior angles sum to 180. I established an equation, and I solved for x using my algebra skills. So I'm going to erase a little bit of this so we can solve for the last problem right here. So let's move some of this out of the way, and maybe I'll make this cleaner, and then we should be ready to go. So look at this last problem, and it says I need to find x, of course, again, and this is our easiest problem so far because these are vertical angles. Vertical angles are congruent. So you can solve by saying 2x equals 130. Divide both sides by 2, and you're getting x is 65 degrees. And there you have it. So that page is now done, and I'll stop the video and I'll do another video for the remaining sections.